Hello friend, welcome to Science for Sleep. Tonight, we're going to spend some time with one of the oldest things any human being has ever known. The sky. Long before there were cities, books, clocks, telescopes or maps, there was already something waiting above every life. A wide dark space filled with light, a place of patterns, motion, color, and mystery. A place that changed slowly enough to feel steady, but strangely enough to make people wonder. If you have ever looked up on a clear night and felt quiet for a moment, then you have already felt part of what made astronomy begin. Astronomy did not begin in a laboratory. It began when people noticed. If you enjoy calm science like this, and you'd like more peaceful journeys through the world and the universe, be sure to subscribe. And now, let's gently begin. They noticed that some light stayed in fixed patterns, while others slowly moved. They noticed that the moon changed shape night after night, then returned again. They noticed that certain stars rose in one season and disappeared in another. They noticed that darkness was not empty at all. It was full of signals. And over a very long stretch of human history, those signals became more than beautiful things to look at. They became guides. They became stories. They became calendars. They became warnings, hopes, questions, and sometimes even answers. That is part of what makes astronomy so special. It is a science now, of course, a very deep one. It measures distance so large that the numbers can feel almost unreal. It studies stars, planets, galaxies, and light that has traveled for ages just to reach us. It asks what the universe is made of, how it changes, and what lies far beyond what human eyes can naturally see. But astronomy is also something older and softer than that. It is the human habit of lifting the eyes upward and feeling that there is more to life than the ground beneath our feet. For most of history, people lived much closer to the sky than many of us do now. Nights were darker. Artificial light was rare or absent. The stars were not faint decorations peeking through city glow. They were powerful, sharp, everywhere. The Milky Way itself could stretch overhead like a pale river of light. The planets stood out. The moon lit the landscape. Darkness had texture, and the heavens felt near. In a world like that, the sky would not have felt like background. It would have felt present. It watched over travel, work, sleep, storytelling, farming, ritual, and timekeeping. It gave human beings a sense that the world moved in rhythms larger than their own. Even people who knew nothing of modern astronomy still knew that the sky mattered. And even today, after so much has been explained, that feeling has not disappeared. In some ways, knowledge has only made it deeper. The stars are no longer just points of light. We now know they are distant suns. The hazy band of the Milky Way is no longer just a glowing cloud. We know it is the inside view of our home galaxy. The darkness between bright objects is not empty. It is filled with structure, motion, history, and things we are still trying to understand. And yet, knowing all that does not make the night sky feel smaller. It often makes it feel even more astonishing. That may be one of the quiet wonders of astronomy. The more clearly people have seen the universe, the more they have realized how much larger it is than they imagined. Not just larger in distance, but larger in meaning. Larger in age, larger in beauty, larger in mystery. For thousands of years, human beings have looked upward and felt something stir inside them. Curiosity, humility, fear, comfort, awe. Sometimes all at once. Because the sky does something unusual to the mind. It reminds us that we are small, but not unimportant. It reminds us that we are brief, but connected to something ancient. It reminds us that no matter where people have lived, what language they spoke, or what story they told about the stars, they all began the same way. They looked up. And once that happened, the sky was never only the sky again. Long before people built observatories, drew star maps, or gave names to planets, there were already human beings standing beneath the night sky and noticing that it was not random. Even in very early times, the sky offered something the earth below did not always offer so clearly. It repeated. The sun rose and set. The moon changed shape, disappeared, and returned. Certain stars showed up in one part of the year, then slipped away. Darkness itself was not always the same. Some nights were bright with moonlight. Others were deep and full of stars. Over time, these changes would have become familiar, and familiarity is often where careful observation begins. For early humans, this kind of noticing was not separate from life. It was part of life. People lived much closer to the land, the weather, the seasons, and the natural light around them. That meant the sky was not just a thing to admire now and then. It was one of the great repeating systems surrounding everyday existence. A person did not need formal science to realize that the heavens moved in patterns. They only needed time, attention, and memory. And human beings have always been good at memory when something feels important. A changing moon is hard to ignore. It grows, rounds out, brightens, then slowly thins away. A bright planet appears in the evening for many nights in a row, then changes position. A familiar group of stars starts rising earlier each night. These are the kinds of details that would have quietly impressed themselves into the human mind, especially in a world without bright streets, glowing phones, or lit windows pulling attention back down. It is likely that some of the earliest sky knowledge was passed along through spoken words rather than writing. A parent might point upward and tell a child when a certain star returns. A group might learn that a certain season begins when a certain pattern appears before dawn. A story might help people remember which stars belong together, or which bright object wanders, or when the moon will be full again. That is one of the most beautiful things about the early history of astronomy. It probably did not begin with numbers first. It likely began with shared attention. Someone noticed. Then someone remembered. Then someone told someone else. And over generations, those small acts of watching and remembering may have built into traditions that became more precise and more meaningful with time. Of course, the farther back we go, the less certain the evidence becomes. It is tempting to imagine that every ancient mark carved into stone or bone was part of a star calendar, or that every prehistoric pattern was a map of the heavens. Some of those claims may hold truth. Others may say more about modern imagination than ancient certainty. So it helps to be gentle and careful here. We do have reason to think early humans watched the sky closely. We do have reason to think the moon and seasonal changes mattered deeply. We do have reason to think that repeated celestial patterns would have become part of memory, movement, and story. But we should also allow some mystery to remain, because not every first observation left behind a clear record. In a way, that uncertainty fits the subject. The beginning of astronomy was probably quiet. No single person invented it. No one night created it. It gathered slowly, like dew. A remembered moon, a returning star, a season announced by the horizon, a pattern seen once, then again, then again. What matters most is that very early human beings were not simply living under the sky without thought. They were already in a relationship with it, watching it, learning its moods, trusting some of its rhythms, wondering about the rest. And once the heavens became something people could compare from one night to the next, the sky changed in the human mind. It was no longer just a ceiling of lights. It had become a source of knowledge. To understand why the sky mattered so much to people in the distant past, it helps to imagine a kind of night that most modern people almost never see. A truly dark night. Not a suburban night with porch lights and passing cars. Not a city night with glowing windows and bright streets. A real dark sky, where the land fades away, the horizon softens, and the stars seem to multiply the longer you look. In that kind of darkness, the sky does not feel far away. It feels present. It feels almost physical, like a great dome of light and shadow hanging close above the world. That alone changes the human experience of looking up. Today, many people grow up seeing only the brightest stars. A few clear points, maybe the moon, maybe one or two planets if they know what to look for. But in the ancient world, without electric light, the night sky would have appeared far fuller. Thousands of stars would have been visible. The Milky Way would not have been a faint idea. It would have stretched across the darkness like a pale river, or a cloud of spilled dust, or a bright path through the night. That kind of sky invites attention. It gives the eyes more to notice, and the mind more to wonder about. Bright planets would also have stood out more clearly. Unlike many stars, which seem to twinkle in the atmosphere, planets often shine with a steadier light. To someone watching night after night, they would have looked unusual, important, different from the fixed patterns around them. The moon, too, would have felt much more powerful than it does now in many modern settings. On bright nights, it could light the ground, shape travel, and give the whole landscape a different mood. In a dark world, the sky was not a thin layer above daily life. It was woven into daily life. That matters. It means astronomy did not begin only because human beings were curious, though of course they were. It also began because the sky was more visible, more dramatic, and more deeply tied to ordinary experience. When people stepped outside at night, the heavens were not hidden behind modern brightness. They were there in full. This also meant the sky could become familiar in a very different way. When something appears clearly, regularly, and over many years, the mind begins to organize it. You start to notice which stars rise together, which season brings which patterns, where the moon appears after sunset, which bright object has moved since last week. That kind of familiarity is easier to develop when the sky is not washed out or half erased. And beyond usefulness, there is something else a dark sky gives: scale. A truly star-filled sky can make a person feel very small, but not always in an unpleasant way. Sometimes it feels calming. Sometimes it feels beautiful. Sometimes it creates a strange mix of comfort and distance, as if the universe is enormous, but somehow still close enough to lean over the world each night. Ancient people would not all have reacted to that feeling in the same way. Some may have felt awe, some fear, some reverence, some simple acceptance. But whatever they felt, they were living with a night that spoke much more loudly than ours often does now. That is part of what makes ancient astronomy easier to understand. People were not staring into a blank black sky and forcing meaning into it. They were responding to something rich, bright, structured, and constantly present. The stars formed dense patterns. The Milky Way cut across the darkness. The moon changed the shape of the night. Planets wandered. Meteors flashed. Eclipses startled. Dawn and dusk carried their own repeating order. Over time, the whole sky would have felt less like empty space and more like a living calendar, a map, a story field, and a source of signs. In many parts of the modern world, that original relationship has been weakened. Artificial light has softened the stars, hidden the Milky Way, and made the night feel smaller than it really is. But for most of human history, the sky remained one of the largest and most visible parts of the environment. And once people began living beneath that kind of brilliance, it was only natural that they would begin turning lights into patterns and patterns into meaning. When people looked up into the crowded night sky, they were not only seeing light, they were also doing something deeply human. They were finding patterns. This is one of the oldest habits of the mind. Human beings naturally connect things. We see faces in clouds, shapes in shadows, and meaning in scattered details. It is part of how we make the world feel understandable. The sky, with its many points of light spread across darkness, became one of the largest pattern fields anyone could ever see. So people began linking stars together, not with lines that were really there, of course, but with lines imagined by the mind. A few bright stars might become the outline of a hunter. Another group might look like an animal, a bird, a river, or a great boat. In Greek tradition, one of the most famous examples is Orion, a mighty hunter placed among the stars. But Orion was not the only possible reading of that part of the sky, or of any part of the sky. The stars were shared, but the meanings were not. That is part of what makes constellations so interesting. The same sky could be read in very different ways. A pattern that became a hero in one culture might become an animal, a tool, or a seasonal sign in another. People in different parts of the world did not simply copy one great sky story. They built their own. Their animals, beliefs, landscapes, values, and memories all shaped what they saw overhead. The night sky gave people the same raw material, but each culture arranged it into meaning in its own way. This does not mean constellations were only imagination for amusement. They were often useful. A story helps memory. A named pattern is easier to remember than a random scattering of points. If a child is told to watch for a certain hunter, bird, or curved shape in the sky, that child is much more likely to remember when it appears, where it rises, and what season it belongs to. In this way, constellations could help pass knowledge from one generation to the next. They turned the sky into something easier to teach. And because stories are easier to remember than bare facts alone, constellations helped preserve sky knowledge long before printed charts or formal astronomy books existed. They also gave the night sky personality. A dark sky filled with countless stars can feel beautiful, but also overwhelming. Constellations help break that vastness into recognizable parts. They gave the eye a place to begin. Instead of facing thousands of stars all at once, a person could notice one pattern, then another, then another. Little by little, the sky became familiar. That familiarity mattered. Once the heavens felt familiar, they became easier to track, easier to compare, and easier to notice when something changed. A wandering planet stood out more clearly when it moved near a well-known pattern. A seasonal shift became easier to recognize when a familiar group of stars started appearing earlier in the evening. Story and observation in this way worked together. And not every culture focused only on bright stars. Some traditions also paid close attention to the dark spaces running through the Milky Way. Instead of seeing only points of light, they saw forms in the shadowed lanes between them. In parts of Aboriginal Australian sky knowledge, for example, dark shapes in the Milky Way became meaningful figures in their own right. This reminds us that sky knowledge was never just one universal map. Different people watched in different ways, noticed different things, and built different heavens. That variety is important because it shows that astronomy first grew inside culture, not outside it. The human mind did not look at the sky as a machine first. It looked at the sky as something full of form, memory, and presence. Only much later would astronomy become more mathematical and technical. In the beginning, it was often shaped through story, image, and repetition. A child might first learn the stars not as objects, but as figures. Not as distant suns, but as companions in the night. And even though modern astronomy explains the heavens very differently, that older instinct has never fully disappeared. People still do it now. Even today, when we know that constellations are not real groups in space, we still trace them. We still name them. We still enjoy the feeling that scattered lights can become something recognizable. Perhaps that is because constellations reflect two truths at once. One is about the sky. The other is about us. The sky offered the stars, but the shapes came from the human mind. As villages became cities and cities became civilizations, sky knowledge became more organized, more powerful, and more necessary. A small group of people watching the moon or waiting for a certain star to rise is one thing. A large farming society, with rulers, temples, taxes, planting seasons, and thousands or even millions of people, is something else entirely. In that kind of world, time had to be tracked more carefully. Seasons had to be noticed more reliably. Rituals had to happen at the right moment. Leaders wanted signs, farmers wanted warning, priests wanted order. And the sky, with all its repeating motions, offered one of the best systems anyone had. So in the first civilizations, astronomy began to take on a new role. It became more organized. In Mesopotamia, especially in Babylon, sky watchers kept careful records of celestial events over long stretches of time. They noted the movements of the moon, the wandering of planets, and the timing of eclipses. This was not only passive wonder. It was a patient effort to observe, compare, and remember. Over time, these records became detailed enough to help predict certain events, which made Mesopotamian astronomy one of the earliest great traditions of organized sky study. That was an important shift. The heavens were no longer only something to react to. They were becoming something people could track with real confidence. In Egypt, the sky was also closely tied to order and survival, but in a different setting. Egyptian life depended on the Nile, and the Nile followed a yearly rhythm that shaped farming, food, labor, and stability. One especially important sign in the sky was the star Sirius. Each year, its return to the dawn sky came near the season of the Nile's flooding. That made it useful as a marker of time and renewal. The sky, in this sense, was not just beautiful above the land. It was connected to the life of the land itself. It helped people prepare. It helped people organize. And because ancient Egypt placed such value on cosmic order, celestial observation fit naturally into a wider view of harmony, kingship, and sacred balance. In China, astronomy also became deeply tied to order, but especially to the order of the state. Court astronomers watched the sky carefully, and celestial events could be treated as signs connected to the health of the realm. An unusual eclipse, a comet, or a strange planetary event was not always seen as a simple curiosity. It could be read as a warning, a message, or a disruption in the balance between heaven and earthly rule. This gave astronomy a serious political role, and it also encouraged long-term record-keeping. Across many generations, Chinese observers built valuable traditions of careful sky observation. The heavens, once again, were not separate from society. They were part of how society understood itself. In Mesoamerica, astronomy also shaped life in lasting ways. Civilizations such as the Maya followed celestial cycles with impressive attention, using them in calendars, ceremonies, and architectural design. The timing of ritual life was often connected to the movements of the sun, moon, and planets. Buildings could be aligned with important solar events. Time itself could be organized through interlocking cycles that joined astronomy, religion, and public life into one great pattern. And this is what makes early civilization astronomy so fascinating. In all these places, the sky was being studied, but not in the modern sense of a clean separation between science and culture. Astronomy was mixed into everything. It was tied to farming because people needed seasons. It was tied to religion because people saw meaning in the heavens. It was tied to kingship because rulers wanted legitimacy and order. It was tied to survival because the timing of nature mattered. It was tied to memory because knowledge had to be preserved. So although these civilizations differed in language, landscape, and belief, they shared something important. They all treated the sky as more than scenery. They treated it as a system worth watching closely. A system that could guide action. A system that could shape power. A system that seemed to connect earthly life with something larger and more enduring overhead. By this point, astronomy had grown far beyond simple nighttime noticing. It had become part of the machinery of civilization itself. The sky was no longer only observed. It was built into calendars, temples, and the structure of power itself. One of the sky's greatest gifts was regularity. It changed, but it changed in patterns. That may seem simple at first, but for early human societies, it was one of the most important things the heavens could offer. A world filled with weather, uncertainty, danger, and change still had one great source of rhythm overhead. The sky did not stay the same, yet it did something even more useful than that. It repeated. The moon was one of the clearest examples. Unlike the stars, which could seem fixed from night to night unless watched carefully, the moon changed in a way that was easy to notice. It grew from a thin crescent to a bright full circle, then slowly shrank again. It disappeared, then returned. This cycle gave human beings something close to a natural month. No clock was needed. No writing was needed. You could simply look up and know that time was passing in a visible, dependable way. The sun offered something larger. Its daily rising and setting created the basic rhythm of day and night. But over the course of a year, the sun also changed its path in the sky. It rose and set in different places along the horizon. The days grew longer, then shorter. Warmth increased, then faded. Plants, animals, and weather shifted with it. This gave people a way to sense the year itself, not just the day. And when people watched carefully enough, certain turning points became especially important. The solstices marked the longest and shortest days of the year. The equinoxes marked the times when day and night stood in near balance. These moments gave societies stable points in the flow of time. They could be used for planting, for ritual, for public gatherings, and for marking the great seasonal transitions that shaped life on the ground. In many places, people tried to bring the moon and sun together into one working system. This was not always easy. A lunar cycle is not a neat match for the solar year. Months based on the moon do not line up perfectly with the seasons shaped by the sun. So many early calendars became lunisolar. They tried to honor the visible rhythm of the moon, while also staying in step with the larger rhythm of the year. This required attention, adjustment, and care. Timekeeping was not only about watching, it was also about correcting. That effort tells us something important. Ancient people were not simply admiring celestial beauty. They were trying to build order from it. In Egypt, this need for order became especially clear. The Egyptians were deeply concerned with cycles, renewal, and stability, and their lives were tied closely to the Nile. One important signal in the sky was the rising of Sirius, which came near the season of the Nile's flooding. Over time, Egyptian calendar systems moved toward a 365-day framework, which made timekeeping more reliable for administration and society. The sky was still being watched, but now it was being translated into a more formal structure. And once that happened, the uses of sky time grew even wider. Reliable celestial cycles could help coordinate agriculture, which meant better planning for planting and harvest. They could help rulers and officials organize taxes, labor, and storage. They could help priests and communities time festivals and sacred days. They could help large populations move together through the year with some shared sense of order. In this way, astronomy became practical in one of the deepest senses. It helped society stay synchronized. It told people when to prepare, when to gather, when to plant, when to celebrate, and when to expect change. That kind of shared timing matters more in large societies than in small ones. A village may work through local memory, and direct experience. A civilization needs something more stable. The sky, because it was visible to everyone and repeated its patterns so faithfully, became one of the oldest public systems of time. And perhaps that is one reason the heavens felt so trustworthy. They were distant, yet dependable. They changed, yet they returned. Long before gears, pendulums, watches, or printed calendars, human beings were already living by rhythms written in light and shadow. A month could be seen in the moon. A year could be felt in the sun. A season could be recognized by where light appeared on the horizon before dawn. Before mechanical clocks and printed calendars, time was written overhead. Among all celestial objects, the moon is the one that feels closest to ordinary life. The stars are countless and distant. The planets move slowly and quietly across the sky. But the moon feels familiar in a different way. It is large enough to notice without effort, bright enough to change the look of the night, and active enough to seem almost personal. It does not stay the same for long. It grows, rounds out, fades, and disappears, then begins again. That repeating cycle helped make the moon one of humanity's oldest companions. Its phases happen because the moon orbits Earth, while sunlight always shines on half of it. As the moon moves, we see different portions of that sunlit half from our position here on Earth. That is why the moon seems to change shape, even though it is not actually being eaten away or rebuilt. Over about 29.5 days, the cycle repeats. A thin crescent becomes a half moon, then a bright full moon, then slowly narrows again into darkness before returning. It is a graceful pattern, easy to notice, easy to remember, and that made it useful. For people living long before modern calendars, the moon provided a visible way to divide time. You did not need special tools to know that nights were passing. The moon showed it openly. A person could tell whether the month was young or old just by looking upward. Whole systems of timekeeping grew around this steady cycle, and many cultures shaped their calendars around the moon's return. But the moon was not only a clock, it was also a lamp. The moon does not create its own light. What we call moonlight is sunlight reflected from its surface. Even so, that reflected light has always mattered. In a world without electric bulbs, a bright moon could transform the night. Fields, paths, water, and rooftops could all become visible in a softer, silver kind of glow. The land itself could feel changed. A moonlit night was not the same as a moonless one. This would have affected ordinary life more than modern people often realize. Night travel was easier under a bright moon. Work that needed some visibility could stretch later. Social life, storytelling, ritual, and movement after dark all took on a different character when the moon was full or nearly full. By contrast, nights without moonlight could feel deeper, heavier, and more uncertain. The moon gave human nights texture. It made darkness variable, and because it changed so clearly, people learned to live in rhythm with it. Coastal peoples also noticed another pattern connected to the moon. Tides rose and fell in regular ways, and over time, careful observers could see that the moon was involved. Long before modern physics explained gravity in detail, people could still recognize that the sea responded to celestial rhythms, The connection was not just abstract. It affected fishing, shore travel, harbor life, and the daily behavior of coastal communities. So the moon worked on many levels at once. It marked time. It changed the brightness of the night. It shaped water. It created expectation. And because it returned so faithfully, it also gathered meaning. It became one of the richest symbols in human culture. The moon appears in myths, songs, prayers, calendars, poetry, paintings, and stories from around the world. Sometimes it is linked with mystery, sometimes with romance, sometimes with rebirth, guidance, fertility, or change. It can feel soft, watchful, distant, or sacred, depending on the culture and the moment. Very few objects in the sky have entered human imagination so deeply. Part of that may be because the moon feels both near and unreachable. It is clearly there. It is large enough to see details in its surface with the naked eye. It changes quickly enough to feel alive in the mind. And yet it always remains beyond the hand, hovering above human life without ever joining it. That mixture of closeness and distance gives the moon a special emotional power. Even now, after spacecraft, photography, and scientific explanation, that feeling has not disappeared. We know the moon is a world. We know why it shines. We know why its phases happen. We know it is not changing shape in the way it seems to be. And still, when a full moon rises low and bright on the horizon, it can stop people in their tracks. It still feels like an event. That may be because the moon has never been just an object to human beings. It has been a repeating presence, a bright face in darkness, a steady cycle above restless lives. The moon was never just an object in the sky. It was a repeating presence in human nights. Most stars keep their places relative to one another. The planets do not. That difference made them special from the start. To someone watching the night sky without modern tools, the stars seem steady in their patterns. Night after night, the same groups rise and set together. They wheel across the sky as a great background of light. But now and then, among those fixed patterns, there are a few bright objects that behave differently. They appear in one place, then slowly drift. They move through the familiar star fields instead of staying locked in place. That is why ancient people found them so striking. They did not yet know these were worlds like Earth, or gas giants, or rocky bodies orbiting the sun. But they could see that these lights were unusual. They were not like the others. In fact, the word planet comes from an old term meaning wanderer, because these objects seem to roam across the sky. 5 planets can be seen with the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. All 5 were known in the ancient world, and each had its own character. Mercury stayed close to the sun and was harder to spot. Venus was brilliant and often appeared near sunrise or sunset. Mars had a reddish color that made it stand out. Jupiter shone bright and steady. Saturn moved more slowly and quietly, but it too could be followed over time. To ancient observers, these wandering lights must have felt both familiar and strange. They appeared often enough to be known, but behaved oddly enough to remain mysterious. That odd behavior mattered. It meant that the sky was not made only of fixed patterns. There were regular stars, yes, but also special lights that travel through them. And because human beings are naturally drawn to what breaks a pattern, the planets became objects of special attention. At first, their movement likely inspired stories and symbolic meanings. A wandering light seems more alive than a fixed one. It seems active, purposeful, almost personal. That may help explain why planets became linked with gods, powers, and influences in so many cultures. A bright object that moved differently from the stars could easily feel like a messenger, a sign, or a force with its own nature. But the planets did more than feed mythology. They also challenged the mind. If the heavens were orderly, why did these lights drift? If the stars held their places, why did the planets refuse to do the same? And most puzzling of all, why did some planets sometimes seem to slow down, stop, move backward for a time, and then continue forward again? This is what we now call retrograde motion. Of course, the planets are not truly reversing course in the dramatic way they appear to from Earth. The effect happens because Earth itself is moving, and our changing viewpoint creates the illusion of a backward loop against the stars. But to ancient astronomers, this was a real puzzle. It was one of the clearest signs that the heavens were more complicated than they first seemed. And that complication pushed astronomy forward. People could not simply admire the planets. They had to account for them. Their wandering demanded explanation. Their strange loops demanded models. Their brightness, timing, and location invited closer and closer record keeping. Over time, careful observers learned that planetary motion was not random, even when it looked confusing. It followed rules, though those rules took centuries to understand. That is one of the most important things the planets gave to early astronomy. They forced people to think harder. A sky filled only with fixed stars might have encouraged pattern and story alone. But a sky that also included wandering lights demanded something more. It demanded tracking, comparison, memory, prediction. It encouraged people to notice that appearances can be misleading, and that nature may hide its order beneath motions that seem strange at first glance. Even today, planets still carry some of that old feeling. When Venus glows low in evening twilight, or Jupiter rises bright and steady, they do not look like distant worlds in the scientific sense first. They look like what they have always looked like to the human eye. Special lights. Lights that stand apart. Lights that seem to move with intention through the stillness of the stars. And for countless generations, that quiet refusal to stay fixed made them some of the most fascinating objects in the sky. The planets looked like stars that refused to stay still, and that refusal pushed human thinking forward. Regular cycles are reassuring. Sudden celestial events are not. For most of human history, people depended on the sky partly because it was reliable. The sun rose. The moon changed in familiar ways. The stars returned in their seasons. Even the wandering planets moved with enough steadiness to be watched over time. The heavens could seem grand, but also orderly. And when human beings live by patterns, they come to trust them. That is why rare sky events could feel so powerful. They seem to interrupt that trust. An eclipse is a perfect example. The sun and moon usually follow their familiar paths without dramatic surprise. But sometimes the geometry lines up in just the right way, and something strange happens. In a lunar eclipse, Earth passes between the sun and the moon, and Earth's shadow falls across the moon. In a solar eclipse, the moon passes between Earth and the sun, blocking the sun from our view for a short time. These events are fully natural, but they do not happen every month because the moon's orbit is tilted slightly compared with Earth's path around the sun. Most months, the alignment is close but not exact. To modern eyes, an eclipse is often exciting. To ancient eyes, it could be deeply unsettling. A bright moon darkening unexpectedly, or worse, the sun itself being partially or almost completely covered in daytime, would have felt like the sky breaking one of its own rules. Day suddenly becomes dim. Shadows change. Temperature can drop slightly. Birds may quiet down. The world feels confused for a moment. Even if a person knew an eclipse might come, the experience could still feel eerie. Without that knowledge, it could seem like a warning or an attack on the natural order. Comets carried a similar power, but in a different way. Unlike the moon or planets, a comet could appear suddenly and change the look of the sky for days or weeks. Its bright head and trailing tail made it look unlike almost anything else overhead. It did not fit easily into the usual patterns. It was not one of the known wandering lights. It was not one of the steady stars. It was something strange, dramatic, and hard to ignore. That is one reason comets so often became linked with upheaval. They were commonly treated as omens, especially in times when rulers, priests, and entire societies were already alert to signs from above. A comet arriving before a war during a famine, or near the death of a king, could be woven quickly into the meaning of those events. Human beings are natural pattern makers, and when something rare appears in the sky, it is difficult not to connect it with what is happening on the ground. Other events had this same effect. Meteor showers could send repeated streaks of light across darkness. A supernova could place a bright new star where none had been seen before. In far northern and southern regions, auroras could fill the sky with shifting curtains of light. These events were beautiful, but beauty is not always calming. Sometimes beauty feels too strange to be comfortable. Sometimes it feels like a message. That emotional mix is important. Rare sky events brought together wonder and fear in a very intense way. They were astonishing to look at, but they also challenged the belief that the heavens were stable and predictable. A calm sky teaches trust. A disrupted sky invites interpretation. That is why so many civilizations preserved records of these events. An eclipse was remembered. A comet was written down. A strange new star became part of history. These moments stood out not only because they were visually dramatic, but because they seemed meaningful. Even when people disagreed about what they meant, few could dismiss them as ordinary. And in a quiet way, these rare events also pushed astronomy forward. The more carefully people recorded them, the more they could compare one event with another. Over time, this helped turn fear into pattern, and pattern into explanation. But that transformation took time. For long ages, the emotional force of these events came first. The sky, which usually moved with such calm repetition, suddenly seemed alive with interruption. And when that happened, people did not simply look up and move on. They paused. They remembered. They told stories. They wondered what had changed and what change might come next. When the sky seemed to break its own rhythm, people did not just watch, they interpreted. Over time, skywatching became more than memory and meaning. It became counting, comparing, and predicting. This did not happen all at once. Human beings did not suddenly stop telling stories about the heavens and begin doing mathematics instead. For a very long time, both ways of seeing existed together. The sky could still be sacred, beautiful, and full of meaning, while also becoming something that people tracked with increasing care. That slow change is one of the most important steps in the history of astronomy. It marks the moment when watching the sky became not just a way of feeling connected to the universe, but also a way of learning how it worked. In Mesopotamia, especially in Babylon, this change became especially clear. Observers recorded the movements of the moon, the planets, and unusual events in the sky over long periods of time. This required patience more than fancy tools. Night after night, year after year, people wrote down what they saw. A planet appeared here. The moon entered a certain phase there. An eclipse occurred at a certain time. At first, these records may have served religious or political purposes as much as anything else. But over time, something powerful emerged from simple repetition. Patterns. Once enough observations were gathered, people could begin to notice that certain events returned in regular ways. A celestial event that seemed mysterious on one night became less mysterious when similar events were seen again and again. What looked like surprise could begin to reveal structure. And once structure is recognized, prediction becomes possible. That was a major turning point. To predict even part of the sky is to discover that nature follows rules. A person no longer has to wait helplessly for every event. They can begin to anticipate. They can say, with some confidence, that a certain phase will return, or that a certain motion is part of a larger cycle. The heavens remain vast and difficult, but they no longer seem completely beyond understanding. Greek thinkers carried this process in a new direction. If Babylonian observers were especially strong in long-term record-keeping, Greek thinkers became especially interested in explanation. They wanted not only to know that celestial patterns repeated, but why they did. Geometry became one of their great tools. The sky looked orderly, so it seemed reasonable that its motions might be described through shape, proportion, and ideal movement. This brought astronomy closer to something that feels more recognizably scientific. The heavens were no longer only signs to be read. They were becoming motions to be modeled. Of course, these early models were not always correct. Some assumptions would later be overturned, but that does not reduce their importance. What mattered was the method beginning to form. Careful observation led to comparison. Comparison led to pattern. Pattern led to models. Models could then be tested against what the sky actually did. This way of thinking changed astronomy deeply. It made the sky into one of the first great subjects where patient record keeping could produce reliable foresight. That is no small thing. In everyday life, the future often feels uncertain. Weather can surprise. Human plans can fail. Crops can suffer. But in the heavens, there seemed to be an order that could be approached through discipline and thought. That must have been both intellectually exciting and emotionally powerful. It suggested that the universe was not only meaningful, but structured. not only beautiful, but knowable. And yet, even as astronomy became more measured, it did not lose all of its older spirit. A predicted eclipse may be less frightening than an unexpected one, but it can still inspire awe. A planetary cycle described with numbers does not stop being beautiful. In some ways, understanding can deepen wonder rather than replacing it. To realize that the sky follows patterns precise enough to be studied does not make it less astonishing. It can make it more so. That is why this part of astronomy's history feels so important. It is not the death of story, it is the birth of a new tool. Human beings were still looking upward with emotion, imagination, and reverence. But now they were also bringing records, measurements, and reason into that relationship. The sky was becoming something that could be approached not only with myth and memory, but with evidence. And once that happened, astronomy began to change from a field of meanings into a field of motions. The heavens were still mysterious, but now they could also be studied as a system. For a long time, it felt natural to place Earth at the center of everything visible. The ground beneath human feet seemed still. The sky above seemed to move. Each day, the sun crossed overhead. The stars turned through the night. The moon traveled across the darkness. From ordinary experience, it made perfect sense to imagine that Earth stood at the center, while everything else moved around it. This was not a foolish idea. It was a reasonable one. If you trust your senses, the heavens do appear to circle around the world. And for many centuries, geocentric models, which placed Earth in the center, gave people a way to organize what they saw. These models could be detailed and mathematically sophisticated. They were not just simple guesses. They were serious attempts to describe a sky that clearly moved, even if the deeper structure behind that movement had not yet been fully understood. Still, not everyone was satisfied forever. Some thinkers began to wonder whether the picture might be reversed. Among them was Aristarchus, an ancient Greek thinker who suggested that Earth might move around the sun. It was a bold idea, but it did not win out. The older Earth-centered view remained stronger for a long time, partly because it fit daily experience so well, and partly because there was not yet enough evidence to make the new picture feel unavoidable. So for centuries, Earth stayed in the middle of the human story. Then, slowly, that began to change. In the 16th century, Nicolaus Copernicus proposed a sun-centered arrangement of the cosmos. In his model, Earth was no longer fixed at the center. It was one of the planets moving around the sun. This did not solve every problem at once, and Copernicus still imagined planetary paths as circles, which left some complications in place. But his model offered something powerful. It made certain motions simpler. The wandering of the planets, which had required increasingly elaborate explanations in Earth-centered systems, began to make more sense if Earth itself was also moving. The strange loops of retrograde motion no longer had to be treated as planets truly reversing direction. Instead, they could be understood as part of a changing viewpoint from a moving Earth. That was a profound shift. It meant that some of the sky's strangest behavior was not caused by the planets behaving oddly, but by us watching from a world that was moving too. Later, Johannes Kepler refined this new picture even more. He showed that planets do not move in perfect circles, but in ellipses. That may sound like a small adjustment, but it mattered enormously. With ellipses, planetary motion could be described more accurately, and the heavens began to look less like a system built from perfect geometric ideals and more like a real physical order that followed its own deeper rules. This changed astronomy in a scientific sense, but it also changed something deeper in the human imagination. To move Earth from the center was not just to move a planet. It was to move human beings, at least in their own minds. The world was no longer the fixed middle around which all things turned. It became one body among others. Important to us, of course, but not placed at the exact center of the visible universe. That realization could feel unsettling. It could also feel liberating. In one way, humanity became smaller. The heavens were no longer arranged quite so neatly around human life. But in another way, the universe became more expansive and more beautiful. Earth was not removed from the story. It was placed within a larger one. And that larger story invited a new kind of perspective. Human beings were now inhabitants of a moving world. The ground beneath them was not the still center of creation in the old sense. It was a planet traveling through space. Day and night were not caused by the sun circling us, but by Earth turning. The yearly path of the seasons was not just the sky shifting overhead, but part of our own movement around the sun. This was one of the great reversals in human thought. The sky had not changed, but the way people understood their place within it had. And once that shift began, it became harder and harder to imagine the universe as something arranged simply around human sight alone. Humanity did not disappear from the story, but it was no longer sitting at the exact middle of it. Then came the instrument that changed the sky from a distant surface into a place full of texture, structure, and surprise. Before the telescope, even the most careful sky watchers were still limited by the human eye. That eye is remarkable in many ways, but it was not built to reveal the fine details of the moon, the small companions of distant planets, or the strange shapes of faraway objects. It could see brightness, motion, and broad patterns. But much of the universe remained hidden behind distance itself. The telescope changed that. It did not change the sky, of course. It changed what human beings could notice in it. And once that happened, the heavens no longer seemed like a smooth, unreachable shell overhead. They began to look like a real place, full of surfaces, bodies, structures, and surprises. One of the first great shocks came from the moon. To the naked eye, the moon can appear smooth and clean, almost like a polished lamp hanging in darkness. But when Galileo turned a telescope toward it in the early 17th century, he saw something different. The edge of light and shadow across the moon was uneven. Bright peaks caught sunlight before lower ground did. Dark regions and rough textures stood out. In other words, the moon had landscape. It had mountains, valleys, and irregularity. That was a profound discovery. The heavens had long been imagined by many as perfect and unchanging, different in substance from the rough world below. But here was the moon, not as an ideal shining sphere, but as a world with texture. It looked less like a perfect symbol and more like a place. Galileo then pointed his telescope toward Jupiter and saw something just as unsettling to older ideas. Tiny points of light stood near the planet, and over time they changed position in a patterned way. These were moons, 4 of them, circling Jupiter. This mattered because it showed that not everything in the heavens orbited Earth. There were centers of motion other than our world. The old image of all celestial things turning around us became harder to defend when another planet was clearly carrying companions of its own. Venus offered another clue. Seen through a telescope, Venus showed phases, much like the Moon. Sometimes it appeared fuller, sometimes thinner. That detail was more than a curiosity. It fit naturally with the Sun-centered model, where Venus circles the Sun inside Earth's orbit. In an Earth-centered picture, these changing phases were much harder to explain. A small, bright point had become evidence. That is one of the beautiful changes the telescope brought to astronomy. It turned light into detail, and detail into argument. The sky was no longer only something to admire from afar. It had become something that could answer back. Then there was Saturn. In early telescopes, Saturn did not appear clearly ringed the way it does in modern images. Instead, it looked strange and confusing, as if it had handles or ears on either side. At one point, those side shapes even seemed to disappear, leaving observers puzzled. It was an object that refused to make immediate sense. Later, Christian Huygens understood that Saturn was surrounded by a ring, and suddenly one of the oddest sights in the sky became one of the most elegant. That moment captures something essential about the telescope age. The universe did not become simpler when people looked closer. It became richer. A planet turned out to have moons. Another showed phases. The Moon had mountains. Saturn wore a ring. What once looked plain became layered. What once seemed distant became textured. What once seemed like a flat arrangement of lights began to reveal itself as a place filled with worlds. And the telescope did more than reveal objects. It changed human confidence. If the eye alone had misled people about the smoothness of the Moon or the simplicity of the planets, then perhaps the universe held many more truths waiting just beyond ordinary sight. That idea opened a new chapter in astronomy. Better instruments could reveal more. More detail could reshape old beliefs. The sky was no longer a finished picture. It was an unfolding one. In that sense, the telescope was not just a tool for magnifying objects. It was a tool for humbling certainty. Each new observation suggested that the heavens were more complex, more physical, and more surprising than they had once seemed. The old sky of symbols and smooth motions was giving way to a sky of worlds, surfaces, companions, shadows, and structure. The telescope did not just make the sky bigger, it made it more real. For most of human history, stars were lights. Later, they became suns. That change may sound simple, but it transformed the human view of the universe. For a very long time, stars seemed like fixed points attached to the sky itself. They kept their patterns. They returned in the same arrangements. They looked small, sharp, and far away, but not necessarily like places. To many people, they felt more like features of the heavens than objects within space. That made sense. The stars do not show obvious shape to the naked eye. Even bright ones remain tiny points. Unlike the Moon, they do not reveal surface detail. Unlike the planets, they do not visibly wander against the background. They appear steady, almost pinned in place. So it was natural for earlier cultures to imagine them as part of a celestial sphere, a great shell of light surrounding Earth. But as astronomy grew more careful, that picture slowly began to change. One important step was the realization that stars are not all equally distant in any simple, flat way. They only look arranged on a single surface because they are so far away. In reality, they are scattered through enormous depths of space. Some are relatively near, at least by cosmic standards. Others are much farther away. They seem side by side from Earth, but many are separated by distances almost too large to picture easily. That alone made the universe feel deeper. The sky was no longer just a decorated ceiling. It was becoming a vast three-dimensional place. Then came another major turning point. Astronomers began to study starlight more closely, not just its brightness, but its composition. When light from a star is spread out into a spectrum, it carries patterns that reveal what elements are present. This field, called spectroscopy, showed something astonishing. Stars were made of familiar ingredients. Hydrogen and helium were especially common, along with other elements found throughout the universe. That was a beautiful shift in understanding. The stars were not made from some special heavenly substance completely separate from Earth. They were built from the same basic kinds of matter found here too. The divide between the heavens and the world below began to soften. The universe was not made of two totally different realms. It was one physical reality. Modern astronomy deepened this picture even more. A star is now understood as a huge, glowing ball of hot plasma. It shines because of nuclear fusion in its core. Under enormous pressure and heat, hydrogen atoms are forced together to form helium, releasing vast amounts of energy in the process. That energy then makes its way outward and radiates into space as light and heat. This means a star is not just burning in the ordinary sense, like wood in a fire. It is doing something far more powerful. It is turning mass into energy deep inside itself. That process gives stars their light, their warmth, and their long lives. It also explains why stars vary so much. Some are small and dim. Others are enormous and brilliant. Some live for very long stretches of time. Others burn through their fuel faster. The sky may look calm from Earth, but the stars themselves are active, physical, and shaped by powerful forces. And once human beings understood that stars were suns, the emotional meaning of the night sky changed too. In one sense, the stars became less mythical. They were no longer simply mysterious lights placed overhead for symbolism or decoration. They became natural objects with structure, composition, and life cycles. But in another sense, the sky became even more intimate. The universe was not made of strange material beyond all human connection. It was made of the same kinds of matter that exist here, in the world around us, and even within us. That is one of the quiet wonders of astronomy. The more the universe is understood physically, the more connected everything can begin to feel. The atoms in the human body were forged in older stars long before Earth existed. The light reaching our eyes from a star has traveled across immense darkness, but it comes from processes that belong to the same universe that made stone, water, air, and life. The gap between Earth and sky remains enormous in distance, but not in substance. So the stars did not become less astonishing when they became understood. They became more astonishing in a different way. They were no longer tiny decorations above the world. They were other suns, scattered through deep space, each with its own story, its own scale, and its own power. The stars were no longer tiny decorations. They were other suns, and suddenly the night became far deeper than it looked. Astronomy has a special quality that few other sciences share. It is always delayed. That may sound strange at first, because the sky can feel immediate. The moon is there right now. The stars are there right now. A planet rises and we see it. But what we are really seeing is not the object as it is in this exact instant. We are seeing the light that has already traveled from it to us. And light, even though it moves incredibly fast, still takes time. This is where one of astronomy's most beautiful ideas begins. A light year is not a measure of time. It is a measure of distance. It tells us how far light travels in 1 year. Because the universe is so large, ordinary units like miles or kilometers can quickly become too small to be useful. Light years help give shape to distances that would otherwise feel almost impossible to picture. But the deeper idea is even more interesting. Because light needs time to travel, looking far into space also means looking backward in time. The sun is a good place to begin. Sunlight takes a little more than 8 minutes to reach Earth. That means when we look at the sun, we are not seeing it exactly as it is in that moment. We are seeing it as it was a little over 8 minutes ago. The same is true for everything else in the sky. Only the delay grows longer as distance increases. The moon, because it is much closer, is seen only a little over a second in the past. Nearby planets are seen minutes to hours in the past, depending on where they are in relation to Earth. The nearest stars beyond the sun are seen years in the past, and distant galaxies are seen so far in the past that their light began its journey long before human beings existed, long before Earth looked the way it does now, and in some cases, long before the sun itself had fully formed. This gives astronomy a very unusual character. Most sciences study things more directly in the present. A biologist can watch a living cell now. A chemist can observe a reaction now. A geologist can hold a rock now. But an astronomer is always receiving messages that are late. Every beam of starlight is a kind of report from earlier times. That is why astronomy can feel almost like archaeology. Not archaeology of stone or bone, but archaeology of light. The farther away an object is, the older the message it sends us. A telescope pointed toward distant galaxies is not only looking across space. It is reaching into earlier chapters of cosmic history. In a sense, the universe keeps old records moving outward in all directions, and astronomy is the art of catching them. This changes the feeling of the night sky. The stars no longer seem like simple decorations in the present moment. They become layered in time. One bright point may be sending light that left years ago. Another may be much older. A faint galaxy in deep darkness may be showing us a version of itself from an age so distant that it belongs to a much younger universe. The sky is not a single moment spread overhead. It is many moments arriving together. That is one reason astronomy can feel so deep. When we look up, we are not seeing one clean snapshot of the universe. We are seeing a mixture of different times, different distances, and different histories all gathered into one view. Nearby objects are telling more recent stories. Faraway ones are telling older stories. The universe appears before us all at once, But it is not all from the same time. And the deeper our instruments can see, the further this reaches. A stronger telescope does not just reveal dimmer things, it also reveals older light. That means better astronomy can become a way of exploring cosmic history itself. It can help people study how stars formed, how galaxies changed, and how the universe looked when it was much younger than it is now. This is one of the quiet marvels of the subject. Distance becomes history, light becomes memory, and the sky becomes something more than a ceiling full of shining objects. It becomes a layered record of a universe that has been unfolding for immense stretches of time. So when a person steps outside and looks up on a clear night, they are doing something more extraordinary than it first appears. They are not only looking outward, they are also looking backward. A night sky is not just a view across distance, it is a view across time. For many people, the Milky Way was once simply a glowing river or cloud. Its true meaning took much longer to understand. On a dark, clear night, far from city lights, the Milky Way can stretch across the sky as a pale band of brightness. It does not look like a sharp object. It looks soft, misty, almost like breath on black glass. For much of human history, people saw it as a path, a stream, a road, a seam in the heavens, or a veil of light. It was one of the most beautiful sights in the night sky, but also one of the hardest to explain. That is partly because the Milky Way does not reveal itself all at once. It is too large, and we are too deep inside it. Today we understand that the Milky Way is our home galaxy. It is an enormous collection of stars, dust, gas, and gravity, all held together in one vast system. But we do not see it from the outside the way we might see a picture in a book. We see it from within. That changes everything. It is a little like standing in the middle of a great forest. From outside, the forest has a shape. From inside, you mostly see a crowded band of trees. The Milky Way works in a similar way. Our galaxy is shaped somewhat like a great flattened disk, and because we live inside that disk, we see its crowded plane as a bright streak across the sky. We are looking along the thickness of the galaxy, through huge numbers of stars packed into the same broad direction. That is why the Milky Way appears as a glowing band, rather than as a neat spiral shape. This was not easy to figure out. For a long time, people could describe the Milky Way only by how it looked. Some imagined it as heavenly milk, smoke, mist, or spilled light. Those images were not foolish. They were honest responses to what human eyes could see. The Milky Way really does look cloud-like. It really does seem like some softer substance spread across darkness. But gradually, astronomy revealed something deeper. The Milky Way was not a cloud laid across the sky. It was the sky, in one direction, made denser with stars. That realization changed the scale of home. The sun, which already seemed so important from Earth, was no longer just a bright center of our local world. It became one star among many inside a galaxy so large that ordinary numbers begin to lose their feeling. The night sky was not simply filled with stars. We were embedded in one enormous star system, living inside it without ever seeing its full shape with the naked eye. That idea carries a strange blend of smallness and closeness. On one hand, it makes human life feel tiny. Earth is not the center of the galaxy. the Sun is not the center of the galaxy. We are living in just one region of one immense system. On the other hand, the Milky Way becomes more intimate when understood this way. It is not some distant object hanging above us. It is the larger structure we already belong to. We are not merely beneath it. We are inside it. That gives the Milky Way a different emotional weight from many other astronomical ideas. Distant galaxies may inspire awe because they are so far away. The Milky Way inspires a quieter feeling. It is the realization that the great river of light overhead is not someone else's universe. It is ours. Or at least, it is the one we are living within. And that can make a dark sky feel more personal. A person looking at the Milky Way is not just seeing a beautiful band across the heavens. They are looking into the larger city of stars that contains the Sun, the planets, and the long history of our cosmic neighborhood. They are seeing home, though home on a scale so large that the mind can only partly hold it. In older times, the Milky Way was a wonder because it was mysterious. In modern astronomy, it remains a wonder for a different reason. It is still beautiful, but now it is also understandable in a new way. Its softness comes from distance. Its glow comes from countless stars. Its shape in the sky comes from our position inside a galactic disk. And its meaning has changed from scenery to structure. The Milky Way stopped being only a sight and became an address. Even after the galaxy became understood, one enormous question remained. Was it everything? For a time, that question was surprisingly hard to answer. The night sky contained many faint, blurry patches that did not look like ordinary stars. Through early telescopes, some appeared as soft clouds or smudges of light. Astronomers called many of them nebulae, which simply meant cloudy objects. But what these objects truly were was not yet clear. Some seemed to belong inside the Milky Way. Others seemed stranger. The difficulty was scale. If the Milky Way was already vast beyond ordinary imagination, then it was natural to wonder whether these faint patches were just smaller pieces inside it. Perhaps they were local clouds of gas. Perhaps they were star clusters too distant to resolve clearly. Or perhaps, more boldly, they were something much larger and farther away. For a long time, the answer remained uncertain. That uncertainty is important because it reminds us that even after major discoveries, astronomy often moves through long periods of ambiguity. People can see something before they fully understand what they are seeing. The universe does not always reveal its meaning all at once. One of the most famous of these blurry objects was Andromeda. To the naked eye, under a dark sky, it appears as a faint, misty patch. Through better instruments, it became more distinct, but its true nature was still debated. Was it a nearby cloud within our galaxy, or something far beyond it? The answer, when it came, changed the known universe forever. Andromeda turned out to be another galaxy, not a small object floating inside the Milky Way, but an entire star system of its own, containing an enormous number of stars. In other words, the Milky Way was not the whole universe in any local sense. It was one galaxy among others. That was a staggering shift in scale. Human beings had already lost the center once when Earth stopped being the middle of the cosmos. Then the Sun became one star among many. Then the Milky Way became the larger home that held those stars. And now, even the Milky Way was no longer the whole great structure. It was one immense system among many immense systems. The universe had opened again. This changed not only astronomy, but imagination. A galaxy is already so large that the mind struggles to hold it. To realize there are countless galaxies beyond our own is to step into a level of scale that almost stops feeling numerical and becomes emotional instead. The universe begins to feel not just big, but overflowing. Not just deep, but filled with separate great cities of stars spread across vast darkness. And they are not all alike. That too mattered. Galaxies turned out to come in different shapes and characters. Some are graceful spirals, with curved arms winding outward. Some are elliptical, more rounded and smooth. Some are irregular, lacking a simple, clear form. Some are rich in young stars and gas. Others are quieter, older, and more settled. The universe was not repeating one design endlessly. It was producing variety on a grand scale. This gave astronomy a new kind of richness. The night sky was no longer simply a local field of stars inside one cosmic home. It became a universe of many homes, each with its own structure, history, and motion. The faintest smudges in the darkness were no longer vague decorations. They were distant systems, each one larger than almost anything human beings had once imagined. And yet, there is something calming in this too. The discovery of other galaxies did not erase the beauty of the Milky Way. It placed it in context. Our galaxy remained home, but now it was home within a larger community of immensities. The universe became less lonely in one sense, even as it became much larger. The darkness between galaxies remained enormous, but it was no longer empty of meaning. It was the space between island universes. That phrase captures the feeling well. Island universes. Each galaxy a vast system of stars, set apart in the cosmic dark, yet part of the same larger whole. This was one of the great enlargements of human thought. The sky had already grown from local lights to a galaxy. Now it grew from a galaxy to a universe crowded with galaxies. And once that happened, the old night sky could never feel quite the same again. A faint blur was no longer just a blur. It was distance on an almost unbearable scale. It was structure far beyond our own. It was another galaxy hanging in the dark. Once other galaxies entered the picture, human scale changed again. The universe became not just large, but crowded with immensities. Even after telescopes widened human vision, they did not reveal everything. In some ways, they only taught us how much remains hidden. At first, a telescope may seem like the perfect answer to distance. If something is too faint or too far away, build a stronger instrument and look harder. And for many discoveries, that approach worked beautifully. Telescopes revealed mountains on the moon, moons around Jupiter, rings around Saturn, and countless stars too faint for the eye alone. But over time, astronomers learned a humbling lesson. Seeing more does not mean seeing all. The human eye is only sensitive to a narrow band of light. It notices the small slice we call visible light, the colors from red through violet. But the universe produces much more than that. There are longer wavelengths and shorter wavelengths, forms of radiation the eye cannot detect at all. So if human beings wanted to understand more of the cosmos, they would need to do more than simply magnify ordinary sight. They would need new ways of seeing. That is why modern astronomy studies the universe through many wavelengths. Infrared light, for example, can help reveal objects hidden behind clouds of dust. A region of space that looks dark or blocked in visible light may open up in infrared, showing stars forming inside. Radio astronomy reveals structures and motions that would otherwise remain invisible. X-rays show some of the most energetic and violent places in the cosmos, such as matter heating up around black holes or the hot remains of exploded stars. Each wavelength tells a different part of the story. No single view is enough. That alone changes the feeling of astronomy. The sky above us may look calm and silent, filled with stars and darkness, but in other wavelengths it becomes far more active, layered, and strange. Dust glows, gas stretches across space. Violent events flash and fade. Hidden regions become visible. The universe is richer than ordinary sight suggests. And even this is only part of the hidden story. Astronomers also found that visible matter, the stars, gas, dust, and planets that can be observed directly, does not seem to account for all the gravity in the universe. Galaxies behave as though they contain more mass than we can see. Their outer regions move in ways that suggest something unseen is helping hold them together. This unseen influence is called dark matter. That name can sound dramatic, but the important thing is to stay calm and clear about what it means. Dark matter is not called dark because it is evil or mystical. It is called dark because it does not shine, reflect, or absorb light in the ordinary way we can detect easily. Its presence is inferred mainly through gravity, through the way visible matter moves under its influence. In other words, astronomers do not claim to see dark matter directly in the usual sense. They see its effects. Something similar is true of dark energy, though it is even more mysterious. Observations of the universe suggest that cosmic expansion is speeding up, not slowing down. To describe whatever is driving this accelerated expansion, astronomers use the name dark energy. But here too, the name does not mean the thing is fully understood. It is a label for a real effect whose deeper nature remains uncertain. That uncertainty matters. It reminds us that astronomy is not a finished map. It is an expanding effort to understand a reality much larger than human senses were designed to grasp. This can sound unsettling at first. People often like the idea that what is real is what can be seen directly. But the universe does not seem to work that way. Much of what shapes it is known indirectly. Gravity reveals what light does not. Motion points toward hidden mass. Expansion hints at deeper forces. The cosmos keeps reminding us that ordinary human sight was never the full measure of what exists. And there is something quietly beautiful in that. It means the universe still has depth left in it. Even after centuries of watching, measuring, and building better instruments, reality continues to extend beyond what seems obvious. The darkness between stars is not simply empty black space. The visible universe is not the whole story. The eye gives us one version of the cosmos, but not the only one, and not the deepest one. So astronomy becomes, in part, an art of listening to clues. Light is one clue. Gravity is another. Motion is another. Piece by piece, human beings build a picture of a universe that is only partly available to direct sight, yet still open to understanding. The invisible universe reminds us that human sight was never the full measure of reality. The sky was not only beautiful and meaningful, it was useful. For much of human history, knowing the heavens was not simply a way to feel wonder. It was a way to move through the world without getting lost. Before compasses, maps, satellites, and glowing screens, the sky offered one of the most dependable guides a traveler could have. The land could be unfamiliar. The sea could be empty in every direction. But the stars returned in patterns, and those patterns could be learned. This made astronomy practical in one of the deepest ways. It helped people survive distance. Across land, travelers could use the sky to keep a sense of direction when landmarks were scarce or uncertain. Across open water, that skill became even more important. A person at sea cannot rely on roads, signs, or fixed boundaries. Water hides paths. Horizons look alike. The world can feel open and disorienting all at once. Under those conditions, the heavens become more than scenery. They become structure. In the north, one of the most useful guides was Polaris, the North Star. Polaris appears close to the north celestial pole, which means it stays nearly fixed in the sky, while other stars seem to circle around it. To a traveler, that steadiness is a gift. If you can find Polaris, you can find north. And once north is known, the other directions can be built from it. That does not solve every challenge of movement, but it gives a stable reference in a world where much else may be shifting. Not every culture used Polaris in the same way, of course. Its usefulness depends partly on where a person is on Earth, and many traditions develop their own methods using other stars, rising points, seasonal patterns, and the relationship between sky and horizon. What matters is the larger principle. The heavens gave direction by repeating themselves. A traveler who knew which stars rose where, or which bright patterns marked a certain season, could use that knowledge as a map written in motion rather than ink. This kind of skill required memory, observation, and practice. It was not enough just to admire the stars. One had to know them well enough to trust them. Some of the most sophisticated examples of this come from Polynesian wayfinding. Across vast stretches of the Pacific Ocean, navigators traveled between islands using an extraordinary combination of sky knowledge, ocean awareness, and mental mapping. They did not rely on a single trick. They watched stars, yes, but also the movement of waves, the behavior of birds, the feel of swells, and the changing qualities of wind and cloud. Navigation was not separated neatly into sky or sea. It was a woven art of attention. Still, the sky remained central. Navigators memorized where stars rose and set on the horizon, and used those positions to maintain direction over long voyages. A star might guide part of a journey, then another would take its place as the night moved on. This required not only astronomical knowledge, but a calm, disciplined relationship with the patterns overhead. One especially famous teaching tool connected with this tradition is the star compass used by Polynesian navigators, including the Hokulea tradition. In this system, the horizon is divided into many directional houses, allowing rising and setting stars to be linked to precise bearings. This shows just how refined sky navigation could become. The stars were not being used vaguely. They were being used with structure. And that is the key idea. Astronomy, in many parts of the world, was not abstract. It was embodied knowledge. It lived in memory, in practice, in movement, and in the confidence to cross distances that would otherwise seem impossible. A skilled navigator did not simply know facts about stars. That person knew how to live with them, how to read them, and how to trust them when the path below offered no guidance. There is something beautiful in that kind of relationship. The same sky that inspired myths and questions also helped people return home. The same stars that stirred wonder also helped prevent disaster. In this way, astronomy was never only about curiosity. It was about orientation in the most literal sense. It helped human beings find their place when the world around them gave few clues. And perhaps that is why sky knowledge was often treated with such seriousness. To know the heavens was not always a luxury. Sometimes it was safety. Sometimes it was skill. Sometimes it was the difference between arrival and disappearance. To know the sky was, in many times and places, to know how to survive distance. Once people saw order in the sky, it was natural to connect that order to questions of fate, divinity, and creation. The heavens were vast, beautiful, and regular in ways that must have felt deeply meaningful. The sun returned. The moon changed in a steady cycle. The stars rose in patterns. The seasons arrived through motions that seemed larger than any one human life. In a world where so much on Earth could feel uncertain, the sky offered a kind of stability. It moved with power, but also with rhythm. And that rhythm invited interpretation. For many cultures, celestial order became closely linked with divine order. If the heavens moved in a dependable way, then perhaps they reflected a deeper structure behind the world itself. Perhaps the sky showed intention. Perhaps it revealed balance, purpose, or the will of higher powers. It is not hard to understand why people would feel this way. The heavens did not seem random. They seemed arranged. And when human beings encounter an arrangement that feels larger than themselves, they often search for meaning within it. This shaped religion in many different ways. The sun might be treated as sacred because of its life-giving power. The moon might be linked with renewal, timing, or mystery because of its changing phases. Certain stars could become associated with deities, ancestors, or moments in sacred stories. In some traditions, the sky itself became a record of creation, a place where the structure of the world could be read above the earth below. Celestial cycles also shaped ritual life. Sacred calendars often followed the movements of the heavens. Festivals could be timed to solstices, equinoxes, lunar phases, or the appearance of important stars. In this way, religious time was often astronomical time. A holy day was not chosen at random. It was anchored to a larger pattern already written into the world. Architecture reflected this too. Temples, monuments, and ceremonial spaces were sometimes aligned with celestial events, such as the rising sun on a particular day of the year, or the appearance of a certain star. These alignments gave sacred spaces a relationship with the heavens. They linked worship on the ground to movement in the sky. This was not only symbolic, it helped make the cosmos feel present in ritual life. Astronomy also shaped ideas about kingship and cosmic balance. In some cultures, rulers were seen as connected in some special way to heavenly order. A well-ordered kingdom might reflect a well-ordered universe. A strange event in the sky, such as an eclipse or comet, could therefore feel politically meaningful, not just visually dramatic. If heaven and earth were linked, then celestial events could be read as signs that something in human society was stable, threatened, or changing. This is one reason astronomy and astrology were often intertwined in ancient settings. Today, those fields are sharply separated. Astronomy is a science. Astrology is not treated in the same way. But in earlier times, the line between observing the heavens and drawing personal or political meaning from them was often much less rigid. The same careful sky watching that helped track planets or eclipses could also be used in efforts to interpret destiny, rule, or divine intention. That does not mean ancient people were confused. It means they were asking different kinds of questions. Modern astronomy often asks what celestial things are, how they move, and what physical laws shape them. Earlier cultures often asked those questions too, at least in part. But they also asked what those movements meant for human life. They were not only studying objects, they were trying to understand their place within a meaningful cosmos. That is worth treating with respect. The goal is not to decide whether those beliefs were right or wrong in some simple way. The deeper point is that the sky mattered enough to shape how people understood existence itself. It influenced ideas about where the world came from, how time should be kept, when rituals should occur, what powers governed life, and how human beings fit into a much larger order. In that sense, astronomy was never only technical, it was existential. To watch the heavens was to ask whether the universe was orderly or chaotic, near or distant, caring or indifferent, stable or full of signs. Different cultures answered those questions in different ways. But the questions themselves rose naturally from the same source: the sky. For much of human history, to study the heavens was also to ask what kind of world we were living in. Modern people know more astronomy than any civilization before them. Yet many now see less of the sky than their ancestors did. That is one of the strangest changes in human history. We understand the moon better. We know what stars are. We have mapped planets, sent telescopes into space, and measured galaxies billions of light years away. In knowledge, we have gained an enormous amount. But in direct experience, many people have lost something simple and ancient: a dark sky. Artificial light has changed the night in powerful ways. Streets glow, buildings shine, parking lots stay bright, signs flash, homes spill light outward through windows and porches. From above, whole cities create a kind of luminous haze that rises into the atmosphere. That glow scatters, softens darkness, and washes out the stars. The night is still there, but it is no longer fully night. For many people, this means the sky has become thinner. Only the brightest stars remain visible. A few planets may still stand out. The moon is still strong enough to cut through the brightness. But the deeper sky, the richer sky, the sky that once carried dense star fields and the broad pale band of the Milky Way, often disappears. A person can grow up in a modern city, and never once see the night as most humans saw it for thousands of years. That is not only a visual loss, it is a cultural one. The shared sky that helps shape myths, calendars, travel, farming, and ritual has become harder to experience directly. It is more difficult to feel the old relationship between human life and the heavens, when so much of the heavens is hidden behind electric brightness. A child can still learn astronomy from books, screens, or classrooms, but that is not quite the same as stepping outside and being surrounded by stars. Something changes when the sky is no longer obvious. It becomes easier to forget. And the effects are not only emotional or cultural. Artificial light at night also changes the body's relationship with darkness. Human beings evolved with days that were bright and nights that were dim. Light after sunset can affect the body's sense of timing, including the rhythms connected to sleep and wakefulness. In that sense, the modern brightened night has altered not only what we see overhead, but also some of the deeper patterns within us. That gives this subject a quiet irony. The same species that learned so much about the cosmos also built an environment that often hides it. We have become better at studying the universe while becoming less used to living beneath it. And yet, the loss is not complete. The dark sky still exists. It can still be found in deserts, on remote coasts, in mountains, across open countryside, and in protected dark sky places where artificial light is limited. When people encounter that kind of night, many are surprised by how full it feels. The stars seem more numerous than expected. The Milky Way can look almost unreal. The sky stops feeling like a black ceiling with a few points of light and begins to feel deep again. That reaction says something important. The human response to the night sky has not disappeared. It has only been interrupted. Even now, many people who rarely see a truly dark night feel something shift when they finally do. Awe comes back quickly. So does quiet. So does perspective. The sky does not need much time to remind the mind that it is larger than daily life. Perhaps that is why the modern loss of the night feels important in more than one way. It is not just that stars have become harder to see. It is that one of humanity's oldest experiences has become less common. For most of history, the heavens were part of ordinary life. Now, for many, they must be traveled to, searched for, or specially protected. That is a remarkable change. The sky has not withdrawn from us. In many places, we have brightened our surroundings until the sky itself has faded. We have illuminated our nights, but in many places, we have dimmed the universe. Even now, when much of the sky is hidden and much of the cosmos is explained, astronomy still has a strong emotional effect on people. That may seem surprising at first. You might think that once something is explained, it would lose some of its power. If we know what stars are, why eclipses happen, how planets move, and what the Milky Way really is, then perhaps the sky should feel less mysterious than it once did. And in one sense, that is true. Many things that once inspired fear or deep uncertainty can now be described clearly. But something else has happened too. Understanding has not emptied the sky of feeling. In many cases, it has deepened it. Part of the reason may be scale. The universe is so large, so old, and so full of structure that the human mind cannot hold all of it at once. A person can learn the facts, but the facts still lead towards something emotionally powerful. To know that stars are distant suns, that galaxies are scattered across enormous darkness, and that the light overhead is arriving from different times, can create a feeling that is not only intellectual, it is personal. The sky has a way of making daily life feel smaller, but not always in a harsh way. Often it feels relieving. Ordinary worries can seem less heavy for a moment when placed beside something so vast. The mind loosens its grip on whatever has been crowding it. Attention moves outward. Breathing may slow. Thoughts that felt urgent can start to look temporary. This is one reason people often describe stargazing as calming. It changes scale. And when scale changes, feeling often changes with it. Researchers who study awe have found something similar. Experiences of vastness, whether in nature, art, music, or the night sky, can create what is sometimes called a smaller sense of self. That does not mean a person feels worthless. It often means the opposite. They feel less trapped inside their own mental noise. They feel connected to something larger. Their own concerns do not vanish, but they stop filling the whole frame. The sky is especially powerful in this way because it combines vastness with quiet. A mountain can create awe. A storm can create awe. The ocean can create awe. But the night sky does something slightly different. It is immense without needing to move loudly. It is overwhelming without forcing itself forward. It asks for stillness. It rewards patience. You do not have to chase it. You only have to look. That may be part of why astronomy can feel both humbling and comforting at the same time. It reminds people that they are small in the universe, but it also reminds them that they belong to the universe. That second feeling matters. The stars are not made of some strange substance unrelated to us. The laws shaping distant galaxies are the same laws that shape matter here. The atoms in human bodies were forged through cosmic history. In that sense, astronomy does not only make people feel small, it can also make them feel included in something ancient and continuous. The distance remains immense, but the separation feels less absolute. And this is where knowledge can actually strengthen wonder. If the night sky were only a black space with lights in it, it would already be beautiful. But when a person knows that one bright point is a planet, that another is a distant star, that the hazy band is our galaxy seen from within, and that the whole scene is layered across time, the sky becomes richer. Explanation does not flatten it. It gives it depth. The mind responds to that depth. It feels curiosity, but also perspective. It feels humility, but also connection. It feels that strange, quiet emotion that comes when something is both understandable and far beyond full understanding. Perhaps that is why astronomy still affects people so strongly. It does not only offer information, it offers proportion. It reminds human beings that their lives are real, but not all-enclosing. That they matter, but are not the measure of everything. That there is a larger reality overhead, one that has been there through countless generations and will remain long after any one moment of worry has passed. To look up is often to feel smaller, but also more connected. After all the measurements, models, and discoveries, astronomy still leaves something open. That may be one of the most beautiful things about it. Over time, the sky moved from myth to mathematics. Human beings learned that the moon shines by reflected sunlight. They learned that planets are worlds, that stars are suns, that the Milky Way is our home galaxy, and that countless other galaxies drift far beyond it. They learned that light takes time to travel, that much of the universe cannot be seen directly, and that even the darkness between things is not as empty as it once seemed. In one sense, the heavens became more explained, but they did not become used up. That is important. Sometimes people imagine that mystery disappears when knowledge grows. They think explanation drains beauty from the world, as if understanding and wonder cannot live in the same place. But astronomy shows the opposite. Again and again, learning more about the universe has made it feel not smaller, but deeper. Not plainer, but stranger in the best possible way. A star does not become less moving when you learn what it is. In some ways, it becomes more moving. It is no longer just a point of light. It is a distant sun, burning across immense darkness. The Milky Way does not become less beautiful when you learn that it is the inside view of our own galaxy. It becomes more intimate. A faint galaxy does not become less astonishing when you realize what it is. It becomes almost unbearably rich with meaning. Even the hidden parts of the cosmos, the parts known through gravity, motion, and indirect clues, do not reduce wonder. They enlarge it. And through all of this, the human relationship with the sky has remained surprisingly steady. People have always used the heavens to orient themselves. At first, that meant practical things. It meant direction, seasons, planting, ritual, and time. It meant knowing when to travel, when to prepare, when to gather, and how to survive distance. But it also meant something less practical and just as important. The sky helped people orient themselves inwardly. It gave perspective. It invited questions. It offered a sense that life was taking place inside something larger than daily struggle. That has not gone away. A person today may know more astronomy than an ancient skywatcher ever could. But when they step outside at night and pause beneath the moon, or a bright planet, or a field of stars, the old feeling can still return. Not exactly the same as before, because the knowledge is different now, but the deeper experience remains. The sky still quiets the mind. It still stretches thought. It still makes ordinary concerns feel temporarily smaller inside a much larger frame. And perhaps that is why astronomy has remained such a steady companion to human life. It speaks to more than curiosity. It speaks to scale. It reminds us that we live on a moving world inside a galaxy, inside a universe far older and larger than anything human beings once imagined. It reminds us that much has been discovered and much remains hidden. It reminds us that understanding is never really finished. Each answer opens into further questions. Each clearer view reveals a wider horizon beyond it. That unfinished quality matters. It means the universe is not only something to master, it is also something to live beneath, something to return to, something to keep company with. The sky does not ask a person to solve it all in one lifetime. It simply remains there, offering itself again and again. A crescent moon over rooftops, a winter constellation rising in the cold, a planet glowing through twilight, a summer sky thick with stars. the Milky Way over a dark field. These are not only scientific sights, they are human sights. They belong to a relationship older than written history. And even now, after observatories, spacecraft, equations, and images from deep space, that relationship is still available in a very simple way: by looking up. That may be the quiet gift astronomy leaves us with. The universe is vast, ancient, layered, partly hidden, never fully finished in human understanding. And yet, it is also present. Present over houses and highways. Present over oceans and fields. Present over cities bright enough to hide most of it, and over dark places where it still pours down in full. The sky can be measured, described, and modeled, but it can never be used up. And that may be part of why it has remained such a steady companion to human life.